National Electrical Code Article 430 covers motor circuits, motor controllers, and motors. National Electrical Code Article 551 covers general-purpose industrial controls. National Electrical Code Article 600 addresses wiring methods and materials. To properly size conductors and protection, begin by determining the equipment requirements. Refer to the equipment manufacturer's specifications to ascertain the voltage, current, and wattage rating. Then select the conductor size, referencing National Electrical Code Table 310.16. Use the current rating of the equipment to select the appropriate conductor size based on the voltage and load. Consider the allowable ampacity reduction factors if the conductors will be bundled or installed in conduit. Next, select overcurrent protection, consulting National Electrical Code Table 430.52. Choose the overcurrent protection device, either a circuit breaker or fuse, rated at or less than the ampacity of the conductors. Also consider the maximum short circuit current available at the location of the receptacle. Finally, install the receptacle. Use an appropriate 480 volts, 60 amps, 3-phase with ground, pin and sleeve type receptacle rated for the load. Install the receptacle in a readily accessible location and provide proper ventilation. Additional considerations are wiring method, conduit, grounding and labeling. Use conductor suitable for the voltage and current rating, such as type THHN or XHHW. Protect the conductors within a conduit to prevent mechanical damage. Ensure a proper grounding path is provided to the receptacle. Clearly label the receptacle to indicate the voltage and amperage rating. Have the installation inspected and tested by a qualified electrician to ensure compliance with National Electrical Code requirements. In greater detail, when dealing with 480 volts power receptacles and adhering to the National Electrical Code, a meticulous approach is essential to ensure safety and compliance. The process begins with identifying the relevant National Electrical Code articles, followed by a detailed procedure for sizing conductors and selecting appropriate overcurrent protection. First, National Electrical Code Article 430 pertains to motor circuits, motor controllers, and motors, which are often connected to 480 volts receptacles in industrial settings. This article provides comprehensive guidelines for the protection and control of motors, including conductor sizing, overload protection, and short-circuit protection. Second, National Electrical Code Article 551 addresses general-purpose industrial controls, which are frequently powered via 480 volts receptacles. This article covers the requirements for control panels, control circuits, and related equipment, ensuring that these systems are safely installed and operated. Third, National Electrical Code Article 600 focuses on wiring methods and materials, providing specifications for the types of conductors, conduits, and other components suitable for use with 480 volts power receptacles. This article emphasizes the importance of using appropriately rated and approved materials to prevent electrical hazard. After identifying the applicable National Electrical Code articles, the next step is to size the conductors and select the appropriate overcurrent protection for the 480 volts receptacle. This process involves several critical steps, beginning with determining the equipment requirements. The first step is to refer to the equipment manufacturer's specifications to determine the voltage, current, and wattage rating of the equipment that will be connected to the receptacle. This information is essential for selecting the correct conductor size and overcurrent protection. Next, consult National Electrical Code Table 310.16 to select the appropriate conductor size based on the equipment's current rating and the voltage of the system. This table provides ampacity ratings for various types of conductors, taking into account factors such as insulation type, ambient temperature, and the number of conductors in a raceway or cable. Consider the allowable ampacity reduction factors if the conductors will be bundled or installed in conduit. Bundling conductors or installing them in conduit can reduce their ability to dissipate heat, which can lower their ampacity. National Electrical Code Article 310.15b3 provides guidelines for adjusting ampacity ratings based on these factors. Once the conductor size has been determined, select the appropriate overcurrent protection device, either a circuit breaker or fuse. National Electrical Code Table 430.52 provides guidance on selecting overcurrent protection devices for motor circuits, while National Electrical Code Article 240.4 provides general requirements for overcurrent protection. Choose a device that is rated at or less than the ampacity of the conductors to protect them from overloads and short circuits. Also, consider the maximum short circuit current available at the location of the receptacle. This information is necessary to ensure that the overcurrent protection device has a sufficient interrupting rating to safely clear any potential short circuit faults. With the conductor size and overcurrent protection selected, the next step is to install the receptacle. Use an appropriate 480 volts, 60 amps, 3-phase with ground, pin and sleeve type receptacle that is rated for the anticipated load. Ensure that the receptacle is installed in a readily accessible location and that proper ventilation is provided to prevent overheating. In addition to these core steps, several additional considerations should be taken into account when installing 480 volts power receptacles. First, use conductors that are suitable for the voltage and current rating of the system. Pipes GHHN and XHHW are commonly used for this purpose due to their high temperature rating and resistance to moisture and chemicals. Second, protect the conductors within a conduit to prevent mechanical damage. Rigid metal conduit, intermediate metal conduit, and electrical metallic tubing are all acceptable options depending on the specific application and local codes. Third, ensure that a proper grounding path is provided to the receptacle to protect against electrical shock hazards. This can be accomplished by connecting the receptacle's grounding terminal to the equipment grounding conductor, which should be sized in accordance with National Electrical Code Table 250.122. Fourth, clearly label the receptacle to indicate the voltage and amperage rating. This will help prevent accidental connection of equipment that is not compatible with the receptacle's power supply. Finally, have the installation inspected and tested by a qualified electrician to ensure compliance with all applicable National Electrical Code requirements. This inspection should include verifying the conductor size, overcurrent protection, grounding, and labeling, as well as performing insulation resistance tests and other checks to ensure that the installation is safe and reliable. To elaborate further, consider the implications of each National Electrical Code article and the nuances of conductor sizing and overcurrent protection. National Electrical Code Article 430, which governs motor circuits, is particularly relevant when 480 volts receptacles are used to power motors or motor-driven equipment. This article provides detailed requirements for motor branch circuits, including conductor sizing, overcurrent protection, and control circuit wiring. When sizing conductors for a motor circuit, it's important to consider the motor's full load current, as well as any applicable service factors or temperature rise limitations. National Electrical Code Article 430.22 specifies the minimum conductor ampacity based on these factors. Overcurrent protection for motor circuits is also subject to specific requirements in National Electrical Code Article 430. The type and size of the overcurrent protection device must be carefully selected to protect the motor against overloads and short circuits without causing nuisance tripping. National Electrical Code Table 430.52 provides maximum overcurrent protection ratings for various types of motors and protection devices. National Electrical Code Article 551, which covers general-purpose industrial controls, applies when 480 volts receptacles are used to power control panels, programmable logic controllers, and other industrial control equipment. This article includes requirements for control circuit wiring, overcurrent protection, and grounding. Control circuits must be protected against overcurrent using appropriately sized fuses or circuit breakers. National Electrical Code Article 725 provides additional requirements for control circuits, including conductor sizing and insulation requirements. National Electrical Code Article 600, which addresses wiring methods and materials, is a broad-ranging article that covers the general requirements for electrical wiring. This article specifies the types of conductors, conduits, and other materials that are permitted for use in various applications. When selecting wiring methods for 480-volt receptacles, it's important to consider the environmental conditions, such as temperature, moisture, and exposure to chemicals. National Electrical Code Chapter 3 provides detailed specifications for various wiring methods, including conduit, cable, and raceway systems. In addition to the specific requirements outlined in these National Electrical Code articles, there are also several general considerations that should be taken into account when installing 480 volts power receptacles. These include ensuring proper grounding, providing adequate mechanical protection for conductors, and clearly labeling all equipment. Grounding is essential for protecting against electrical shock hazards. All metallic enclosures and equipment must be properly grounded in accordance with National Electrical Code Article 250. Mechanical protection is necessary to prevent damage to conductors from physical abuse. Conductors should be installed in conduit or other approved raceways to provide adequate protection. Labeling is important for identifying equipment and preventing confusion. All receptacles and enclosures should be clearly labeled with their voltage, amperage, and other relevant information. To further ensure safety and compliance, it's recommended to consult with a qualified electrical engineer or inspector during the design and installation process. These professionals can provide expert guidance and help ensure that the installation meets all applicable National Electrical Code requirements. The design process also necessitates a thorough understanding of the intended use of the 480-volt receptacles. For instance, if the receptacles are intended to supply power to variable frequency drives or other equipment that generates harmonic currents, additional measures may be necessary to mitigate the effects of these currents on the electrical system. These measures may include using harmonic filters or oversized neutral conductors. The installation of 480 volts receptacles also requires careful attention to detail. All connections must be made securely and in accordance with the manufacturer's instructions. Conductors must be properly terminated and supported to prevent strain on connections. Receptacles must be mounted securely and protected from physical damage. After the installation is complete, it's essential to perform thorough testing to verify that the system is functioning properly and that all safety requirements are met. This testing should include insulation resistance tests, continuity tests, and voltage and current measurements. Any deficiencies that are identified during testing must be corrected before the system is placed into service. It's also important to establish a regular maintenance program for 480 volts receptacles and related equipment. This program should include periodic inspections, cleaning, and testing. Any worn or damaged component should be replaced promptly to prevent safety hazards. In addition to the technical aspects of installing and maintaining 480 volts receptacles, it's also important to consider the human factors involved. All personnel who work with or around these receptacles should be properly trained in electrical safety procedures. They should be aware of the potential hazards associated with 480 volts electricity and know how to respond in the event of an emergency. Finally, it's important to remember that the National Electrical Code is a constantly evolving document. It's updated every 3 years to reflect new technologies and best practices. Therefore, it's essential to stay up to date on the latest National Electrical Code requirements to ensure that electrical installations are safe and compliant. A deep understanding of these National Electrical Code articles, combined with meticulous attention to detail and a commitment to safety, is essential for ensuring the safe and reliable use of 480 volts power receptacles in any application.